Okay, I think we'll get going. My name is Adrian Jackson, and I'm giving a presentation here about Slurm, the scheduler we have on ARCHER2, a little bit about the differences between it and ARCHER, the scheduler we have on ARCHER PBS, and how you'd use it on ARCHER2, and then far too much detail towards the end of the talk on schedulers in general and why you should care about them and what they do. I should say up front, lots of this material is actually from a colleague of mine, Yakovos, who knows a lot more about schedulers than I do and has put a lot of work into these slides. So I'm just a front man for this and not the brains behind the brawn. But hopefully there's enough in here to be useful for you using ARCHER2, either the 4-cabinet system, which is just coming online now, or the larger ARCHER2 system when it's up and running. And then if you want to stick around, there's more details on scheduling in general. So I've structured the talk in such a way where we go through the ARCHER2 specific stuff right up front, and that should take the first 20 minutes probably, 20 minutes, half an hour, and then you are absolutely free to leave whilst I waffle on about schedulers more generally for the next, well, I think I've got 59 slides, so probably the next 4 hours or something like that. As with all these kind of talks, please do feel free to ask any questions as we're going on. You're more than welcome to open up your mic and speak, but also there's a chat where you can type in your messages, and I'll try and keep my eye on that as we're going along, although the technology is slightly clunky, so I may miss it for a minute or two. Good. These slides are licensed under Creative Commons license, so feel free to reuse them, although I don't imagine you'll find them massively useful for reusing elsewhere. Okay, so let's just jump in at the front end. I've not included details of ARCHER2 here because I'm assuming that everybody who's joined sort of knows about it. You know, we now have the ARCHER2 4-cabinet system up and running, 1,024 nodes. Each node has 128 cores, so it's, you know, reasonably big. It's about, in core terms, about as big as the current ARCHER system, although that's because each node has quite a lot of cores. So, node by node basis is about a fifth of the size. But one of the big differences you'll see from a user perspective, going from ARCHER to ARCHER2, is that we're using a different scheduler and a different job launcher. And sort of those are two different aspects. Quite often, as a user, you experience them as the same thing. They're all part of your batch script, and they're what you use to run your jobs. But they are two separate aspects, and we're using two different things here compared to what we had on ARCHER. So on ARCHER, if you're a user of ARCHER, you'll hopefully know that we run the PBS scheduling system there, and that has commands such as qsub to submit a job, or qsub minus capital I to submit an interactive job, qstat to query how your job is doing or how other people's jobs are doing, qdel to cancel a job, either before it started to run or whilst it's running. And then there's a number of other things you can do. Maybe most people don't use these on ARCHER, but something like qstat minus q will tell you something about the overall state of the system, and there are other commands, PBS nodes and things like this, which you get to work out what's going on in the system. Now, as a user, quite often you don't need to know that, but it's there. And actually, when we come to Slurm, it's quite, in a lot of ways, easier to get that information, so it may be more useful to you. And alongside the scheduler on ARCHER, we had the job launcher, the thing which was responsible for taking your application and starting it once you were given a set of nodes. And there we used Cray's AP, or we still do use Cray's AP run, which is their own resource scheduler manager, which interacts with the PBS, but does something different and something separate itself. And if you have any in-depth experience of using ARCHER, you'll have known that the AP run command also kept track of how many nodes you'd been allocated, and you couldn't run multiple jobs on the same nodes at the same time. So it was launching your jobs, but also keeping track of what jobs you were running and what allocations. For ARCHER2, we're now on Slurm scheduling system. Not a choice, I wasn't involved in the choice, but Slurm is quite widely used around HPC systems now, partly because it's open source and free. Or if you need support for it in development work, you can pay for that as well. But it's a free open source, and actually a scheduler you can play around with the source code and extend if you want. And I know here at EPCC we use it for a number of research projects where we're looking at sort of new system features and scheduling, those kind of things. And it has a similar kind of interface to PBS. And in fact, actually, not that I'm going to talk about it, Slurm actually does support a bunch of PBS commands as well. So qsub is an alias to qsub, which will do something similar in the Slurm environment. So they're not unaware of PBS and its functionality. Anyway, briefly, for Slurm, you have sbatch to submit a job instead of qsub. If you want to submit an interactive job, you have salloc instead. So this is, Slurm allocate me some nodes, and I'll show a bit more detail of that later on. If you want to query the status of the job, instead of qstat, it's now sq. And as with qstat, you can query for all the jobs, or you can query for your own job by passing in a username with a -u flag. scancel deletes a job instead of qdel in exactly the same way you would on Archer. You do scancel and then the job ID, the number you were given when the job was submitted. And then sinfo will let you query the status of the system, so see what nodes are available, what nodes are free. And again, this is probably less interest to everyday users of a system like Archer or ARCHER2, because the system generally is pretty full, or will be when it's in production mode, and you just submit your jobs and they run in the future. But the sinfo does let you see what's going on in the system. And then for the ARCHER2 setup, we are also using the Slurm job launcher. So we're using something called srun to take an executable and run it on all the nodes and the cores you've been allocated, and set it up and set up the placement and binding of your MPI processes to cores and your OpenMP threads to cores as well. So that's what we're using there. Now, again, I won't go into too much detail on this, but Slurm can be slightly confusing in that you can do things with sbatch and srun that are similar. So it is possible that instead of submitting a batch script using sbatch, to use srun, and it will give you a set of nodes, and then to srun from inside that another executable. So Slurm is multifunctional in the way you can launch jobs. You can do sallocs and sruns, you can do sbatches and sruns, you can do an srun followed by an executable or another srun, and it will let you do all those. In general, we are just suggesting two approaches on ARCHER2: sbatch of a batch script to run it, and salloc if you want to do an interactive job, with the same caveats that we have on Archer. For interactive jobs, you may take a while to start, and so you may have to hang around at that terminal until the job starts, unless you're running in something like the short queue. So just to dive in straight off the bat, to see what it looks like. On the left-hand side here, I've got the output from a terminal I've run on ARCHER2, the current 4-cabinet system, which is up and running now. On the right-hand side, there's the output of me running a command on Archer, the existing login nodes there. And this is here the info command on the left-hand side, and qstat -q on the right-hand side, which is basically tell me something about the overall queues in the system. Slightly different syntax and slightly different context actually here between Slurm and PBS. But you can see that on my left-hand side, I've done sinfo. I've said Slurm, tell me the information on the system I'm running on here. Now, it doesn't look very nice here because the lines have wrapped around a little bit. And actually, these, well, let me see if I can, my pointer options, my laser pointer. There we go. These lists of node IDs down here would be much longer in general. I've just made them shorter so they fit on this slide. Basically, Slurm tells me all the partitions that are available in the system and the different states of the nodes in those partitions. You can see it currently when I captured this on the 4-cabinet system, one partition. And so for Slurm, a partition is a sort of physical set of nodes. And at the moment on a 4-cabinet system, we only have one set of nodes, a partition called standard, which includes all the 1,024 nodes that are in the system. And it tells me, oh, the standard partition is up. It's got a particular time limit on it, which here is 48 hours. And 45 nodes are in the down state, and it gives me a list of them all. The 10 nodes are in a draining state, which basically means something's gone wrong with them. The batch system has taken them out. They're not physically turned off, so the batch system can still talk to them, Slurm can still talk to them. 5 are in a reservation. 513 are allocated to jobs, and 447 are idle. And one is down, properly down. So there's 2 different kinds of down, but you don't need to care about it. It just means that a handful of the nodes are out of the system at the moment. The majority of your nodes are either sitting with no work on them or are sitting running. So I have a question. Okay, yeah, good question. So in the full Archer system, there will be GPU nodes. They're not in this current 4-cabinet version, and they'll be in the full system when the 23-cabinet system is up and running later on. I will say a little bit more about that in a couple of slides' time. Yes, as the question points out, once we have other kinds of hardware in the system, so particularly we'll have some big memory nodes, which have twice as much memory, I seem to remember, than the normal nodes, and we'll have a small number of, like a development system for GPU nodes. It will go into a different partition. And so you would see that not as a standard partition, but for instance, a GPU partition or a high memory partition. That would show up here. Yeah. When you're a user on the system, of course, because it's a production platform, you need to have some way of specifying that you can run jobs. Now, I've got slightly ahead of myself here because I haven't told you how to run a job yet. But just to illustrate again some of the differences between Slurm and PBS, one of the commands I find useful on Archer is this budgets command, which actually is a little tool, I think, written by EPCC, possibly Andy Turner, EPCC. That goes and tells you what budgets you have access to and what resources you can run on those. And that's linked into the SAFE accounting system, the budget's there, and then enforced on the job submission so that you can't run jobs where you don't have any budgets. And so on this right-hand side, you can see that I have access to some budgets with resources in and some budgets without. And if I tried to submit a job to Z01 test, for instance, it wouldn't work. Z19 CSE would let me run the job. On the left-hand side, we don't have such a nice tool, but Slurm is managing these budgets directly itself with input from SAFE. So we can talk to the Slurm system and say, please tell me what budgets I have access to. Unfortunately, the command is a little bit more involved, but we use this tool from Slurm called S-Account Manager. And we can say, show me the associations where my username is Adrian Dre, because it's my username on the system, and print out the account, the user, and whether I have a budget there or not. So this max T res mins is what we're using to specify whether you have a budget on the system or not. And if it's unset, then you can run. And if it's set at 0, like here, CPU equals 0, that means you haven't got any budget and you won't be able to submit a job. When you submit a job, it will say that you don't have a budget, or it may give you a message such as, resource allocation not accepted, or something like that. In fact, I will try in a second to see what the exact message is. I should have put that in here. I forgot. So you can see here that we're using Slurm now to do the account enforcing, and you can talk to Slurm and see what's going on. And when I run a job on my system, just as on Archer, when I want to submit a job, I have to tell it how to use, what budget to use. here I have on ARCHER2 exactly the same thing, and I only have access to this Z19 budget. I can run on that, but if you are running inside a consortium or a project, you'll have access to your own budgets, you know, N02, N03, E268, these kind of things. I hear another question. Right, okay, so for the Slurm accounting, let me just cycle my slides back a second. David, I assume you're asking that here it just gives you CPU equals 0 or it gives you nothing, right? It doesn't tell you how much time it has. Yeah, okay, this is correct, yes. So the way we have set this up, the integration between SAFE and Slurm, is that if your budget gets depleted in SAFE, then the SAFE runs a ticket which sets CPU equals 0 here in the Slurm system. So it goes and talks to Slurm and says CPU equals 0. Other than that, it doesn't tell Slurm how much time you have here. So if you have a budget, you know, if you don't have anything set in this column, max T-res mins, then you can run a job. Now, off the top of my head, I can't remember what we've done here to make sure that you can't run a massive deficit here by running a full system job when you've only one AU in the SAFE, or one CU in the SAFE, should I say. I think there is something in place which checks. I'll have to go back and refresh myself and talk to Stephen about the SAFE details on that there. That's one for the future. Yeah. Okay, so as I said, we can also check what jobs are running. So, you know, I appreciate I haven't told you how to run a job yet, but we'll get there. And this is using this SQ command on ARCHER2 versus QStat on Archer. And so you can see SQ shows you something similar to the QStat. It tells you job ID. And here, you know, there's a couple of jobs running, 2 jobs were running, and their IDs were 30,749 and 30752. Partition to standard, because as I say, that's all that we have. You give the job names, you get the user IDs, and then this ST here is the status of the job. Now, both these jobs are running, so this is an R. If there are jobs waiting to run, that would be a Q. And if the jobs are finishing, that might be a C or a CR. You can see how long the jobs have run for and how many nodes you're using. It'll give you how many nodes, and then it'll give you a node list here. So again, I have ellipsed this because this was 512 nodes, so it'd be quite a long list going down here. Or if your job is not running, it will say, instead of a node list here, it will say why the job's not running. It'll either say priority or resources. That either means you're not running because there's no free resources for your job yet, or you're not running because you have other jobs that are running and they're ahead of the queue, but your job will run once that comes up. So if it says resources or it says priority, generally both of those just mean the job's waiting for some resources to come free or for another one of your jobs to finish in the future, and then you can run. Okay, so this is probably the thing you're actually more interested in. How do I write a job script and submit a job? And again here, this is actually taken from the ARCHER2 documentation, so I should have put a link in here, but the ARCHER2 website has documentation which has example job scripts which will tell you how to do this. And so we can see here on the left-hand side is an ARCHER2 Slurm batch script. And on the right-hand side, we've got a PBS ARCHER batch script. And we can see that in a lot of ways they're very similar. In Slurm, so we have sbatch job name, and I've given it a name, and this is very similar to the PBS-N, although it doesn't have quite the same restriction. PBS only lets you have a certain number of characters here. Slurm's a bit more generous in that. I'll answer my questions in a second. Then you have time instead of wall time, but again, it's hours, minutes, seconds you specify here. When we tell it number of nodes, just like in Archer, we had select equals 43. This here is the number of nodes. Here I'm running 1,024 jobs. I needed 43 nodes. Over here, I'm saying run on 4 nodes. And then I specify how many tasks I want to run per node and how many CPUs I want to run per task. And if you're just running a vanilla MPI job where you want all the cores to run MPI tasks, then this is what you would run here. 128 physical cores, 1 CPU per task. Now I need to specify this here. We can put defaults in here, but we need to specify this here because this comes back to how this controls how the S run, which I'm running down here, will bind my application, my processes, and my threads to specific cores. So for a standard MPI job, this is what it would look like. But we'll have an example in a couple of slides' time about how we do this for hybrid or OpenMP jobs as well. Then we have an account code, sbatch account equals, and this is where I would put my Z19 in here. Z19 in here. Again, you can get away with removing that line because all your accounts have a default account code, default budget. When your account is first created, it gets the budget of the project it's first created in. But your account may belong to multiple budgets, so it's always good practice to specify the specific budget you want to use here, because either your job will try to run and you'll be linking against the budget that's not got any time in it, or you may charge against the wrong budget and those kind of things. So just specifying here the account and you keep you right. And then there's these two things which are required as well, partition and QoS, quality of service. So we need to specify what partition we're submitting to and what quality of service we're submitting to. And I will talk a bit more about what quality of service means. Partition is just a group of nodes. And as I've said, on the current 4-cabinet system, we only have one partition. This is called a standard partition. So that's just the one you will use. In the future full ARCHER2 system, there may be a couple of different partitions, but for most users, it will be standard. And then there's srun, which launches my jobs. I want it to bind to cores, and again, for most MPI jobs, this is the default. If you want to do something more esoteric, like use the hyperthreads, then you may want to change this and bind to threads, CPU bind equals threads rather than cores. But at the moment, this is what is useful for most jobs. And that's very similar to the AP run. You can see we're not specifying this N here because actually Slurm is working out, it knows I've got 4 nodes. It knows I want 128 tasks per node. It's going to run this job here on 512 cores. It's going to run me a 512 process MPI job. Now I can specify N in here if I want that to be different. But by default, Slurm will pick up what I specify up here and give me the maximum number of tasks I can run. If I wanted to run multiple jobs inside the same batch script, I could say n equals 1 to 8 here, put 4 of them in, and it would assign each one to a separate node and it would run them separately. I can hear multiple questions coming in here. Okay, thank you. People are answering them for me, so I don't have to do the job. That's great. But yes, CPUs per task means no hyperthreading. If you change that to CPUs per task equals 2, then you could get then Slurm will bind things to hyperthreads, and you can use up to 256 things per node. Okay, so in reality, Slurm and the setup we have here is more flexible than what we run on Archer currently, because the AP run job launcher is quite restrict about what you can't share nodes between different jobs inside the same batch script. So if I wanted to run across, if I asked on ARCHER2 over here for 43 nodes, but I wanted to share some of those nodes between different steps in my job, the AP run job launcher wouldn't let me do that. It would serialize them, so only one could run after the other. But the Slurm srun here, I can do a bit more sharing of resources inside this individual job. Now, I've not got an example here. It's a bit more complicated, but I could run multiple srun commands inside this one batch script and utilize the same resources of the same nodes that other sruns in that same side that inside that same batch script are using. So that is definitely possible. Now we can't share the node allocation between different batch jobs. If I submit 10 jobs, I can't share the nodes between them because we're running an exclusive mode here. So each node that's assigned to a job is only used by that one batch job. But inside that batch job, I can have multiple job steps, which are these srun commands. I don't have to have a single one here. I can have multiple ones. And I can run some of them at the same time if I want to, just by putting an ampersand at the end and saying run this in the background, and then putting a wait in there at the end to stop the batch script finishing prematurely. As I said, to do an interactive job, so it may be useful for debugging or for other kind of investigations to be able to run commands directly rather than inside a batch script. To run an interactive job, that's slightly different on ARCHER2 than it was on Archer. Instead of using the same command I used to submit my batch job, IES batch, I'm now going to use something called salloc. It actually says to Slurm, give me an allocation of nodes, and then I'll run stuff on it once I get that allocation. I'm not going to tell you up front in my batch script what I'm going to do. So on Archer, that would be a Q sub minus I, capital I. Then you tell it how many nodes you want, how long you want to run it for, and it will say, you know, we're waiting for the job to start, and when those nodes come free, then you'll get a command prompt. And here you can see I've got command prompt running on what's called the mom3 node. So on Archer, we have these job launcher nodes called mom nodes, which are a separate set of nodes from the login nodes, but not the compute nodes. And they're a place where your job gets started from, and that's where the AP run command starts from. On Slurm, we don't have these job launcher nodes. Sorry, on ARCHER2, we don't have these job launcher nodes. Actually, Slurm just uses the first node in your allocation. So when you submit a batch script or when you submit an salloc command request, and that is granted, you get a set of nodes. The first node in that set is the job launcher node. So it will launch your job from there and then just use that node as normal. And so I don't get a mom node on ARCHER2. And you can see here, I do very similar things as in my Q sub. I've got an salloc. I tell it how many nodes I want. And then the rest of it is very similar to a batch script we saw before. How many tasks per node, how many CPUs per task, the time the job runs for. I still need to put in this partition equals standard, QoS equals standard, and an account code if I don't want it to charge my default account code, which is best practice. And it will say, okay, at some level, it will, if the system's busy, it'll sit there waiting, and then once it's ready, it'll say you've been granted a job allocation. That's the number of it. That's the batch number of it. And it's waiting for resource configuration. This takes very quick, not long at all. And then it tells me what nodes I have. And I've got this terminal back. It's still on the. It still looks like I'm on the login nodes. I'm still on the login nodes, but if I type an srun command from here, it will launch that srun command on these nodes that I've been given here. So if I did srun executable, I've been given 8 nodes, it would run that on 1024 cores on those nodes. It wouldn't run it on the login nodes themselves. So that's how the srun, the interactive allocation goes. It is done through Slurm. Sorry, I was just reading one of the questions in the chat. Now there is no limit on how you run your nodes here. So salloc has access to exactly the same partitions and QoSs as sbatch does. But of course, if you say salloc and you want to ask for all 1024 nodes on the 4-cabinet system, you may have to wait a while. It may take you hours or days before you've been granted this resource allocation. That's probably not a sensible way of using this. Just as with Archer, one of the sensible places to use this interactive access is with the short queue. So I'll I haven't introduced it yet, but we have a short queue set up on ARCHER2 as well, and that would be a sensible place to run this because you should get jobs back from there pretty quickly. But to answer your question, Mark, there is no limit to the number of nodes allowed for interactive jobs. Any user at the moment can run on the full system and could ask for that to be interactive. Whether you would get the allocation back in a sensible time for you to be able to use it sensibly is a different question. You know, it might come back at 4 in the morning and you'd have to be sat at that terminal to do something sensible with it. But certainly that's allowable inside the batch scheduler. One thing I haven't actually investigated, which I probably should have done, is whether you can get Slurm to email you once the allocation has been granted, because I know you can do that in PBS. I honestly haven't looked on Slurm. I'd be surprised if you couldn't, but I don't know. Okay, and then the final thing, really, other than placement and binding of processes and threads, is what is the configuration of a batch system on Slurm. So as I've said, we have, at the moment, we have this ARCHER2 single partition, has all 1024 nodes in it. It's called standard. As I said previously, it's likely when we have the full ARCHER 23 cabinet system, there'll be another partition which has the high memory nodes in it. Probably called high mem, but that may change. I'm not guaranteeing it'll be called high mem. And that's not going to be there until we get the high memory nodes anyway. We don't have any high memory nodes in the 4 cabinet system. And the other thing I should say is actually the way Slurm lets you do partitions, you can put the same physical resources in multiple partitions. So just because the high memory nodes are going to be put off into a separate partition doesn't mean they're only you can never run a full system job across all the nodes on Archer because they're high memory nodes in a different partition. Actually, what we'll do is we'll put all the nodes in the standard partition and then also put the high memory nodes in the high memory partition, so that when you run a job on the standard partition, you may end up in a high memory node, but you may not. But if you submit it to the high mem partition, you would always end up on a high memory node, but it may take your jobs a little longer to run because you're restricting the number of nodes your job can be scheduled onto. And then it's likely when we get this small GPU testbed with the AMD GPUs and the full system, we'll have a partition for that as well. But that, again, is not going to be until next year, till the full system is up. That's the partitions. At the moment, it's very simple. You don't have to do anything about it. There's just one, and it's standard. And the quality of service configuration on Slurm lets us then do things like specify the number of jobs users can have, specify how long jobs can run for, all on top of the same partitions. So at the moment, we have 3 QoSs set up. Standard, which lets you run jobs from 0 up to 24 hours, and you can use all the nodes in the system. So you can run a job from a single node all the way up to 1024 at the moment, with the caveat that if you run a 1024 node job, it may take longer to, it's likely to take a lot longer to start than a 1 node job. Just nature of scheduling being scheduling. And then we have 2 other QoSs set up at the moment. One's called long and one's called short. The long one lets you run jobs which are over 24 hours but under 48 hours. If you try and submit a job to that which is under 24 hours, you will get an error when you try and submit a job and it won't let you submit it. So it has to be over 24 hours. And you can ask for a maximum of 64 nodes per user in that quality of service setup. That means you can have 1 job which is 64 nodes, or you could have 8 jobs with each 8 nodes, or 64 jobs which were each 1 node. But that's the maximum you can ever have in the long QoS. Now, 64 nodes doesn't sound particularly big, compared to what you could run on an Archer system. But then just remember that 64 nodes is actually 8,192 cores. But it should still let you run reasonably long jobs. A slight complication, unfortunately, with a long queue is that at maximum, the scheduler will allow half the system cabinet systems of 512 nodes to be running at any one time in the long queue. So you could have and that's across all users. So you could have a bunch of jobs sitting in the long queue, which should, you would hope, run, because you're not using up to 64 nodes, and there's nodes free, but it won't run because the setup is that a long queue can't use more than half the system. So there's a slight caveat there that may be times when, even if there's nodes free in the overall system, your long job won't run because of this, and it's just worth being aware of. And then at the other end of the spectrum, we have a short queue, which is designed for debugging, really, and it lets you run up to 4 nodes for jobs up to 20 minutes. And you can only use that in combination with a reservation. So what systems do is they set up a reservation that runs between 8 in the morning and 8 at night, Monday to Friday. And then if you want to submit to the short queue, you would say partition equals standard, partition equals standard, QoS equals short, reservation equals short QoS in your S batch. And that would let you get into the system. So we'll update the documentation online to get that there. But effectively, it's just a normal job, but instead of your QoS equals standard, your QoS equals short, and reservation equals short QoS. Sorry, those two are a little bit complicated, the long and the short, but generally should be easy to use. And then there's limits on what you can submit. So on the standard queue, you can have up to 16 running jobs and 16 jobs queued. So you can have 32 jobs in total, but only ever 16 at any one time running. And on the short queue, you can have 1 running job and 2 jobs queued per user. So I should say the caveats to this are the partitions that are not currently available may change in the future. So the definition and how they're included, so particularly the GPU one, but also the high memory one. And then these resource limits we have on the long and the short queue, so 64 nodes on the long queue and 4 nodes on the short queue, may change in the future as well. So we would expect on the large system that these would be bigger, but we have nothing confirmed on that at the moment. Great question, Doug. How would these? I haven't put an example in on job arrays, which I definitely should have put an example in on job arrays. How would these job limits apply to job arrays? So just a quick introduction if people are not aware. Slurm, like PBS, lets you run job arrays where you define a single batch job, you submit it to the system. That inside that batch job, it runs. You can specify it to run multiple separate batch jobs effectively, and so you can run sort of 1,000 batch jobs from a single submission. We do know this. I just off the top of my head, I think what happens is that the batch system for an array job will respect those running job limits. So if you had, say, submitted a batch job, an array job which was going to spawn 100 array tasks, you could only ever have 16 of those array tasks running at once, and the rest would sit waiting. Is my recollection of how this is configured, but I will check that and make sure that that's properly in the ARCHER2 documentation if it's not already there, which you could. But it's a good question. Okay, and so finally, the interesting thing for some people may be if you don't just want to do vanilla MPI jobs where you fill the whole node up with tasks, with processes, should I say? How do I control that from the batch system? And so that's all. It gets slightly complicated, unfortunately, because we have to specify some things to the srun. Basically, you control how many processes you run in the system by specifying tasks per node. Actually, you don't need n tasks here. you could get away with not having any tasks here, but it's not terrible practice to have it here, so it's clear in the script what you're doing. I could specify 4 nodes, 8 tasks per node, and then 16 CPUs per task. Okay, and so this is what's going to do is if I run a job on here, it's going to run me an MPI job with 32 MPI processors, and each has 16 physical cores assigned to it. And then down here, I can specify my number of OpenMP threads to be 16, tell it to bind to cores by default, OMP places equals cores. So this is avoiding the hyperthreads. And I should have introduced that properly, but the ARCHER2 nodes have 128 physical cores per node. Each one of those has 2 hyperthreads, so you can run 256 threads per node. And then I say here, srun hint equals no multi-thread, distribution equals block, and that will run my check. And that will take my job and it will run 8 MPI processes per node, 16 OpenMP tasks per process, and they will be bound in consecutive order. So first MPI process will start on core 0 on node 0, and then its threads will go core 0, 1, 2, 3, 4, 5 up to 15. And then the next MPI process would be on core 16, and its threads would go up to 32. Okay, and so this hint node multi-thread distribution block is there to control how the OpenMP threads are bound to the MPI process and its assigned cores. So we make sure we get consecutive. Now I don't have to say OMP equals 16 here. I could say OpenMP equals 8 or 4 or 2, and it would still do a sensible thing. It would still give me the first 2 cores assigned to each processor. I would be leaving some of the physical cores empty then. That's perfectly acceptable to do if you need to underpopulate for memory sizes or for things like that for performance. And indeed, actually, in some of the benchmarking we're doing, you can see you get best memory bandwidth out of these AMD nodes if you don't fill it up completely with processors. So I can get better better memory bandwidth on my streams benchmarks if I run 32 tasks in a node and spread them out across all the cores. So if I did hit, that would equate to doing tasks per node equals 4 here, and CPUs per tasks task per node equals 32 here, CPUs per task equals 4, and I ran my pure MPI streams benchmark on that. It would give me better performance than if I ran it on 128 processors in the node. It's just the way the hardware is set up. So it may be beneficial to underpopulate for some applications, although you may have to use more nodes to be able to parallelize as far as you want. So it gets a bit more complicated here if you want to do something slightly different. If you want to use the hyperthreads, then this hint would change here. If you want to round robin some of the tasks rather than, so that you don't put all the first 4 MPI tasks on the first node and the second 4 MPI tasks on the second node, etc. If you wanted to go first node for first task, second node for second task, and then come back round, you would change some of these from block to cyclic. I won't go into detail in here, but we have examples in the documentation, and we'll augment those examples with more interesting ones, particularly for hyperthreading, as time goes on. Are there any questions about the placement? Because the placement, yes, so absolutely, Mark. If you underpopulate with no MPI, you can space out onto the NUMA regions. So the OMP num threads down here, you don't have to put in, right? You can just say tasks per node, CPUs per task, and that will spread your MPI jobs out across the cores in the processor and in the node, and that will give you, groupings which are spread across the NUMA regions or the different memory sections of the processor. But absolutely, that's the right thing to do. And then you can fill it up with MPI, OpenMP threads if you want. You don't have to. Entirely up to you. Is there any other questions about placement? As I say, the general, if you turn everything up, what standards there? Task per node equals 1 to 8. CPUs per task equals 1, and everything will work as expected. If you want to underpopulate, that's fine. You just specify less tasks per node, but it's useful to specify CPUs per task as well, not leave it as one. Otherwise, all your cores will start in the first CPU and you'll lose memory performance because you're not using all the memory bandwidth. So if you say you only wanted to run 64 MPI tasks per node, you'd set tasks per node as 64 and CPUs per task as 2. That would spread you out across the processor. And as Mark here says, get you across some of those NUMA regions. You don't have to necessarily care what that means. It just means you're accessing all the available memory bandwidth. If you did task per node equals 64 and CPUs per task equals 1, then you'd use all the cores on the first processor in the node and none of the cores on the second processor in the node. And you'd see some performance impact from that probably because you're losing half your memory bandwidth. Any other questions? Okay, so that's all I wanted to say about the Archer specific setup. As I say, most of this stuff is documented well online, hopefully. If you find inconsistencies or things you don't understand, then absolutely do get in touch with us for the help desk, or you're more than welcome to email me directly. My email's here. Or you can even tweet me if you want. Because it would be great to get more comprehensive documentation if that's required, particularly for some of the use cases which are less default than usual. So multi-threading, hyper-threading, strange placement across the nodes, all those things are possible. It's just we haven't documented them all at the moment. That's all I wanted to say about the Archer system. And as I say, this setup here as well, the QS is a thing. I don't think that's fully documented online yet, but will be documented very shortly. So it should be a good reference. Claire will correct me, maybe it's already there, but if not, that shortly will be a good reference online as to this setup. So what you can run and how you submit the jobs to the different configurations, and when that changes for the full system, I will come back and give another presentation and go for it again. I think probably be sensible. That's all I wanted to say about ARCHER2. Then I've got loads of slides on what a scheduler actually does. But given that I've got 8 minutes left and I think 40 slides left, what I'm actually going to do is skip over all this detail here because I don't think we need to go into it too much. The only part of the detail which I think is potentially interesting for you as a user of a system like Archer, ARCHER2, is how the scheduling is done on a system like ARCHER2 and Archer indeed. And so one of the important things to understand is something called backfill scheduling. And this is the idea that jobs are submitted that use resources. And then the scheduler is always going to try and schedule the jobs that are submitted so that it knows what's running in the future. So we've submitted job 1, job 2, and job 3, and it's assigned these to resources. And then someone submitted job 4, and it needs these specific resources here, so it can't run yet until so we're still here at this time here. It can't run yet until job 1 and 2 are finished. So the scheduler has said, okay, as soon as job 1 and 2 finishes, I'm going to run for, this is when it's going to start, because job 2 told me it's going to run for 8 time, let's say these are hours, 8 hours, and job 1 told me it's going to run for 4 hours. So I'm going to schedule that to start in 8 hours time. And then someone else submits another job, and it can fill that. So it can submit that job there because there's no resources, there's resources available. That's fine. And then there's another job submitted which requires some of these resources, so it has to be scheduled again in the future. So we now, okay, it's going to be after job 4. Job 4, it 2 runs for 8 hours. So 16 hours into the future, job 6 is going to run. Job 7 comes along. There we go. And so in this backfill scheduling, what the scheduler is doing is saying, okay, I'm going to submit, I'm going to try and schedule the job. I'm also going to look at some of the gaps between now and when the latest job is and see if I can fit it in there. Okay, so it's backfilled this job into a hole to try and get it to run quickly. Otherwise, it would have to, in a first in, first out situation, you can say that we have to wait for our jobs to finish before we can schedule the next jobs in it. So we have these gaps in here which are not being filled up because jobs are being submitted. So we can see that backfilling is a great thing to do because it fills in these empty holes in the job schedule based on when you think jobs will run. And there's two ways these holes can appear. One is the holes can appear because the nature of jobs, this is going to run for a different length of time to this one. Job 2 and job 1 run for a different length of time. Job 4 is going to. So we can say, actually, you know, in the future we can see this hole is going to appear. We also get holes in the schedule when jobs finish earlier than they said they would. So this job said it's going to run for 8 hours, but actually if it finishes after 4 hours, the scheduler can't move job 4 forwards. Unfortunately, it's not how they work because it becomes too complex because it's probably scheduled job 6 here and job 8 up here and job 15 over here, and it would have to move them all forward. And then some of these would depend on other jobs. And so the complexity of that scheduling task becomes too hard to do in practice. So if a hole appears here because the job's finished earlier, the scheduler will also try and backfill those holes. And that's why submitting jobs with reasonable time limits on them. You know, don't submit a job with 12-hour time limit if you know only ever going to run for 1 hour, because the scheduler is going to take a while to schedule it because it's going to try and find that 12-hour slot. Whereas if it finds if you say 1 hour, it can find a 1 hour slot where a job finished early and just pop it in there. That's you know, it's always sensible to have your wall times. Now, of course, it's also annoying if your job gets cancelled, you know, gets killed by the scheduler because you didn't specify long enough wall time. But if you can have a sensible wall time, particularly for small jobs where you're just trying things out, 10 minutes, 15, 20 minutes, you're much more likely to get a job running quickly because it will fit into some hole in the schedule, which the backfilling will do here. And the other thing to sort of realize is that Slurm itself does multiple kinds of job scheduling. So actually, it does scheduling in a bunch of places when a job's submitted, when it's completed, and when a configuration takes place. And so it will try and do quick scheduling to start with, and then do this backfilling later, try and fill it up. So you may find that jobs start quickly and some jobs start slowly, and it depends on what part of a scheduling cycle it's sitting in. And so that can impact your scheduling and how your job runs in the future. Okay, so a couple of questions here. Does that mean that 48 nodes in 12 hours is better than 24 nodes in 24 hours? It's hard to answer that question, unfortunately. It may do, but because you're asking for more nodes, it depends on what holes are available in the system. So in general, the shorter you ask for, the job you ask for, the easier it is to find a gap in the schedule to fit it into. But if that means you're going up to large numbers of nodes, then it may be hard for the scheduler to find that and may have to schedule it in the future. So unfortunately, there's no easy answer to whether you should go short and wide or long and thin on your jobs. And the only sensible thing I can say is, you know, specify a wall time which is sensible, and your job is likely to run quicker than specifying a default, you know, 12 hours when you don't need that, unfortunately. And then there's a great question: is there any AI engine to optimize the job fitting? There's lots of research that goes on into scheduling and scheduling systems, and people are looking at AI to do some of that. The real challenges in scheduling is, one is there's a real fixed time constraint, so you need your scheduling to run quickly. You could always do a better schedule in the future if you had longer time, but there's got to be some trade-offs made there. And then the other one is, you know, what your schedule looked like in the past may not reflect what your schedule looks like in the future because your users change over time. And so for AI, from an AI point of view, machine learning point of view, it can be quite hard to see if there are any sort of default patterns there. But yeah, people are working on this. There are not not any deployed machine learning optimized schedules as far as I'm aware, but I know there are a number of research projects that do this. And there are a whole range of choices you can make for the scheduler, which is, you know, interesting to have a look at. Probably beyond the production system like Archer, it'd be a nice little research project to do. Is there any other questions? Right, this is a good question. Can Slurm tell you when your job will run? I don't remember off the top of my head, I'm afraid. I know PBS can potentially do that. I will. If you email me, Mike, I will have a look. I will check, and I'll get back to you with a sensible answer on this. My gut feeling is Slurm can tell you when a schedule will run. It depends on the configuration of Slurm. I'm not sure whether we have that functionality enabled on ARCHER2 or not. But email me and I'll get back to you. Any other questions? If not, or if a question, if a question comes up later, or you actually get access to a system and start playing with it, and something doesn't work, then do feel free to get in touch. As I say, either through the help desk or my email address is on the slides here. And otherwise, that's at the end of our slot. So I will finish there. And thank you for coming along, and hope it was useful for you. And the recording will be up shortly, I believe, possibly tomorrow, it tells me. But otherwise, get in touch if you have any questions.